Okay, so we've been talking about systems of equations. So again, let's review what that is. A system of equations is two or more equations with the same variables. When solving a system of equations, we are looking for solutions that will satisfy each of the conditions given in the equation. Okay, and we talked about previously a substitution method is one way that we can solve a system of equations. Another way is what we call the elimination method. So this is another strategy that's used for solving a system of equations. Where the two equations are added together in order to eliminate a variable. So what happens when we're dealing with these systems of equation is that we have two unknowns. Because there are multiple equations, there's two unknowns, and we have to be able to solve for one of those unknowns. So we have to, in some way, get rid of one of those unknowns. So in the last method, the substitution method, we found out that we would isolate one of those variables to find out what it was equal to so that we could replace that variable with that expression. For elimination method, we're actually going to put them in such a way that we can add these systems of equations together, the two equations together, and that will eliminate a variable. So we're going to start with another guided example today. So the first guided example here is Jeremy's grandmother has gone to the flea market to purchase some new DVDs for her collection. Movies are $2 each and TV shows are $4 each. She took $150 out of her ATM to spend. She looked around her apartment and thought she had room for twice as many TV shows as movies and a total of 48 DVDs. If she wants to use all her money in available space, how many of each TV show and movie will she need to buy? Okay, so we have a lot of important information here. We have movies are $2 each and TV shows are $4 each. She has a total of $150 and she has room for a total of 48 DVDs with twice as many TV shows as movies. So those are all important pieces of information. So ultimately we have two conditions that need to be met. She needs to spend a total of $150, no more, no less, and she needs a total of 48 DVDs. So that's going to be kind of our focus for these two equations. So the unknown things that we don't know is how many TV shows and how many movies. So I'm going to use X to represent the number of movies, and I'm going to use Y to represent the number of TV shows. Okay, so I'm going to create these two equations. So I know that the condition, one of them is $150 and the other is a total of 48. Now I know that the number of movies plus the number of TV shows should equal 48. But I also have another piece of information here that she has room for twice as many TV shows as movies. So 2 times the TV shows plus the number of movies will give us a total of 48. Now on top of that, she also has some number of movies and TV shows that's going to equal $150, but we have to also include how much each of those she's going to pay for them. So it was $2 per movie and $4 per TV show, and that allows us to represent the total amount of money that she wants to spend. Alright, so now that we've got our two equations ready to go, we need to look at our equations. Now, if necessary, we need to multiply one or both of these equations by some number. We're going to call it a magic number. It's not really magic, it's mathematical, but it's a magic number to create opposite coefficients for one of the variables. So we want, for example, a 2 and a negative 2. or a 4 and a negative 4, because they'll be opposite of each other, so that when we add them together, one of the variables will disappear. So what happens here is I'm going to multiply this bottom one by a negative 2. That'll give me opposite coefficients. So what I end up with here when I multiply, and I have to multiply everything in the equation by this magic number. So negative 2 times x becomes negative 2x. Negative 2 times 2y becomes negative 4y. And negative 2 times 48 becomes negative 96. Now, I'm going to keep the top equation originally just like it is. So 2x plus 4y is equal to 150. And then what happens here is we're going to add these two things together. So 2 and negative 2x becomes 0. 4 and negative 4y becomes 0. And 150 plus negative 96 is going to be goodness, I just blanked. 54. Yeah, 54. Okay, now what we wanted to happen was for one variable to cancel out and leave me with just another variable. But what happened here is that both of them canceled out, and I'm left with 0 is equal to 54, which is not a true statement, and so we just ended up with no solution. Okay, and what that means is this: both conditions cannot be met. There's no solution to this problem. So unfortunately that happens sometimes, and Grandma is going to have to come up with another idea of what she wants to be. She's going to have to be more flexible and make a different amount of space, or she's going to have to purchase a different number, or be willing to spend more or spend less than what she was. She's going to have to be flexible. Otherwise, there's no way that she can satisfy all the conditions that she wants to meet. So, correct answer is there is no combination of movies or TV shows that will meet both conditions Jeremy's grandmother has said. And unfortunately, that's just how it happens sometimes. Sometimes there is no solution, and we know that from other equations that we've worked with. Now, I am going to do a few examples of things that do have solutions with you so you can see how it actually should work. So that'll be in the next set of problems that we practice.